Okay, let's talk about jump game 2 in LeetCode. So you are given a non-negative integer number. So your initial position at the first index, and each element in the array represent your maximum jump. So in this example 2, right, the maximum jump could be 3 or 1, right? So that would be the first step and second step. So your goal is to reach the last index in the minimum numbers of jumps. So you can assume that you can always jump to the last index. So when you say you can assume to always reach the last index, you can actually traverse to the second last, because this index will also give you another step to the last index, right? So this is how we actually think about it. So for first index, 2, 2, 3, 1, 1, 4, in this example, you can actually jump either 3 or 1, right? And 3, you can actually either jump 1 or 4, right, to reach the last index. And for this one, you can also jump 1, and this index also jump 1. So let's think about when you do. So when you add 2, you have to pick the greatest number, right? So you will pick 3. So when you pick 3 and when you reach the last index, and then you can actually just break. So this is how you actually do. So what happens when you jump to the integer which is 0? I mean, you don't care about it, because when you jump 2, you can either pick 3 or 0, right? So don't worry about it. So let's talk about think about how it actually goes. So I'm going to say my jumps is my return value. So that will be jump, and I do have a current end. So that will actually know where I am right now, and I'm going to record the farthest, so which is distant from my current position to the future position. So I'll say far equal to max up. So it's either myself or the current position plus the numbers. So when I add index 1, I can know my index 1 and its value 3 will reach the last index. So 1 plus 3 will reach the last index. So this is how I actually memorize how far I can jump. So that would be really important. So when I actually traverse every single element in the array, I can just pick the greatest far. The greatest far for its current value, and we can actually do a computation. We can actually do where I am, and I can say if I am less than or equal to the I would just make sure I will set to the farthest distance and just add the jump by 1. So if I equal to current m, so that was the really beginning, right? So I would say jump plus plus, and also current n would become far. So I didn't actually choose 3 or 1. I'm going to say my current n would be 2. So when I go to here, when I equal to 1, so when I equal to 1, the far will be 2, right? But 1 plus 3, 1 plus nums 1, which is 3, right, is 4, right? So far is actually equal to 4 right now. And since I is not equal to 2, so when I go on the next for loop, which is the next index I, when I equal to 2, the current value, 2 plus 1 is 3, is less than 4, right? Because we already know the farthest, the maximum far is actually 4. So when I equal to 2, when 2 equal to 2, jump plus plus, and current n will become the farthest position I have reached in the array. So that is how it is. And they just run it and see how I did. So this is definitely okay. So if you are worried about like when can you break the array quickly, because the current n will actually greater equal to the nums length minus 1, right? So you can actually break over here, or or return the jump right here. It doesn't matter, it should be the same. So they just run it and see what happens. Yeah, exactly the same result. So let's talk about the time and space. So you are actually not using space. This is pretty local value. So I would say all of 1, and time is you are actually traverse every single element in the array. So it will be all of n, and think about it, it's actually like preferred search. You visit one and you know the current max distance for your current position with its value, and you're going to compare like when you at this position, which farthest distance you have ever reached in the previous step or your current step. So you just actually record it. So that would be the entire solution, and I hope you get it. And this is pretty standard and it's pretty hard as well. So peace out.